this talk kicks off kind of our last track of talks, which are kind of all API-centric or all in the kind of the API vein. So first up is Josh Elser. He's with Hortonworks. He is a Accumulo committer, PMC member, and his talk's going to focus on alternate APIs beyond Java for leveraging Accumulo, something I think's really needed by a lot of people. So with that, Josh.
Thanks, Dan. So given that it is 2 p.m. on the second day, we'll try to have a little bit of fun here. Like you said, we're going to try to cover some ways you can actually use Accumulo that don't require using Java. And some of you probably, if you've been using it long enough, you have at least become numb to it, if not enjoy it mildly. So you could consider, maybe we'll subtitle this as I'm just really tired of writing Java, and I just want something fresh, right? I can do it. It's just boring. It's not exciting anymore. And if you're getting like me now, it's sort of like I'm really sick and tired of writing the same options parsing, writing the same command line tools, the same boilerplate to do the try catches. What happens if a mutation gets rejected? And you end up writing the same hundreds of lines of code over and over and over, and yeah. So hopefully today we can actually cover some stuff that maybe introduces some to bring some freshness back into your Accumulo life. So there's a lot of stuff here. By no means is this a conclusive list for all things that you can do. I tried to pick the ones that I was most familiar with, and I think the ones that have the most traction. So these are facing for you, most likely something that you would have the most success with. Top ones we want to cover, Apache Pig, Hive. We'll go over the Thrift proxy inside of Accumulo. We'll go over what that actually means, because it's kind of obtuse when you just look at it. We'll touch briefly on some of the other JVM-based languages that are not Java, so your Clojure, Scala, more functional or Lispy-like languages. We'll touch briefly on some other things like Cascading and Scouting, and Spark a little bit. So if we want to take these sort of diverse different projects, we want to have some sort of basis of comparison between them all. We want to say, we can look at this, we can say it has strengths and weaknesses, but how does it compare to everything else? So how can we make some sort of common ground between all these different ways to actually use Accumulo? So I picked 5 out here. Maturity, stability, performance, extensibility, and ease of use. It's intentional that there's no numbering here. I don't want to tell you what is good for you, and I really can't. It is really use case dependent. You need to sort of do the legwork on your own to say, these are the problems I have, these are the things that are important to me, and these are the tools I can best use to solve my problem efficiently and optimally for yourself. So performance-based and also your own time, because that's really important, how much time you actually have to invest to solve some problem immediately, as well as from a sustainment point. So maturity, let's go through and define this a little bit so it's just not obtuse terms that I throw up on a projector screen at you. Yeah. So how well adopted is the thing that you're actually using? Is it some dude who sat in his basement or apartment building on a Saturday night at 1 a.m. and put something on GitHub and said, oh, this is awesome, you should use it? Is there a community around it? This is a sort of a topic that keeps coming up again the last 2 days. What is the actual environment around this code base? Is there formal methods? Are there testing? Is there a way for you to actually use it? Is there defined processes? You apply a patch, you get feedback, someone eventually commits the patch. Is there sort of this environment that you can actually use and interact with it, with the code, and not just pull it off of a GitHub or wherever and figure it out on your own? And this really boils down to the importance of this is that you actually have to realize what your big picture, what your spread of software that you're using in your application actually looks like. You're always going to have some amount of code that you write yourself. The lesser you can actually sort of increase your dependency scope and actually have to worry about things that you're using, the more likely that it is more maintainable from that stance. So if you write less code, it's less stuff you have to look at, and hopefully other people are going to be looking at the other code for you and fixing things sort of behind your back without you even having to know about it. Stability is an important thing that's really been coming up lately in at least a lot of the Apache projects that I follow. And really this has to do with how well defined is there an API that defines what you are intended to use. So you hear this a lot thrown around with a thing called semantic versioning. Semantic versioning is just this document that sort of says, here are a set of rules that say for a versioning scheme for software. Here are rules that say changes in these three different bits of a version, so x.y.z. It defines what is actually permissible for the developers of a project to change. So this typically is stated as a major, minor, and patch or bug fix. So things like semantic versioning for an API through bug fix is the code that you write against one version of that bug fix should always compile and run against another version. What those methods actually do when you call them may change, but you never have to recompile, or you never have to change your code to work against a different bug fix version. And then subsequently, as you move up, minor is less stringent than a patch, and major is even less stringent than minor. But this is it's a nice tool for projects to adopt because it is very clear and straightforward about what you should actually expect from a project. And when you're using it and you find, hey, this didn't make sense. You said this method was here in 1.6.2, but it went away in 1.7.0. What gives? You actually have recourse to then say, hey, you guys screwed up. So it gives you, again, it reduces the amount of work you actually have to do. Now upgrading becomes less scary. You can actually have reasonable assumptions of what is expected to work. This is something that others that I've worked with in the recent past have sort of harped on me a lot, and it's really gotten me to think about it. And I think there's a lot of importance in this to actually consider when you choose some software library to use on your own. Performance is one of these great ones that everyone likes to talk about because graphs are really pretty. This is also probably one of the most important aspects that go back to the original point of you need to do some testing on your own. Every use case is different, and as such, performance can be very different things as well. Maybe you're not really running an application with very stringent SLAs. You don't have, 99th percentile of query responses in sub-second. Maybe a query is taking 5 seconds is acceptable. Maybe they're batch, ad hoc analytics sort of type things, and they take order minutes, and that's fine. So these are all sort of varying levels of what can be defined as performance. So really, what I guess you can think about is another way is it fast enough for what I need to do? And really, if it isn't, is it actually reasonable for me to spend any amount of time to figure out how to make my use of that code more optimized, if not actually submitting patches up to some other product to fix some issue that they have? Ease of use is a big one. This goes back to your time being important to yourself. Nobody really wants to be pulling 10-hour days, 5 days a week. Sometimes it happens. It's really nice when you can actually just sit down and you can express some problem in a very natural and fluent way. So you don't have to worry about working around obtuse interfaces and models. It's just very intuitive. You can sit down, you can look at some code, you can figure out what you need to do, and when you come back to it maybe weeks, months later, it's actually, you can look at it again and like, oh, right, I remember what I was doing here, and it makes sense. You don't have to go back and relearn topics. It doesn't take a lot of effort to go and write something new if you realize you made a mistake a couple weeks or months ago. And extensibility is one of these things that I've sort of found in actually, I guess a meta point, is that when you're thinking about how products integrate with Accumulo, in this specific case, you start looking at the thing you're integrating with. So a lot of the things I start to think about now is how extensible is what we're writing in Accumulo to enable users to do what they need or want to do. Additionally, then you start thinking about, you go to another level. It's like, so if I'm working on some integration with Accumulo, how does Accumulo itself enable that integration? So you kind of go down this hop of chains of this. Are my writing things that are generally useful and not going to sort of drive people into this box because we didn't really consider another way of doing things? So we have these 5 points. So let's kind of make a basic comparison. We'll use the Java API with Accumulo. This is sort of one of those things that you see over and over again on mailing list discussions if you follow the Accumulo lists. And you always see this thing called the client API. It's this really like ominous thing, and it really just refers to what, in Accumulo sense, how we apply a set of classes in Accumulo, and we put them into the restriction that semantic versioning sets. So these are meant to be anything user-facing that we expect you to normally use with Accumulo sits in this public API. The problem with this is that it's very difficult to sort of write a good API that is general enough that it's not going to inhibit what you need to do, but actually makes it easy enough you can do everything you want to do. So it's very hard to sort of balance this. So for Accumulo sense, the maturity is actually, I would say it's very good. And there's been a lot of people who've been thinking long and hard about this for many years now, and they've done a really good job to actually say, do these methods that we present to users actually make sense? Are we delivering them a TV with a screen, but there's a piece of wood in front of the screen that they can never look at? Is it actually making sense for them to use, and does it enable them to do the things they want to use? For stability, I mentioned, Accumulo is now following semantic versioning since 1.6.1, which is a little funny if you think about it, introducing this in a patch release. But this has helped. It's really knocked out a lot of bugs, and hopefully is becoming more and more stable as we release new software. Going back to actually enabling you to do what you want to do, these methods, in addition to being clear and succinct, we also want them to be performant so that you don't have to do excessive complicated things just to write data at high throughput or read data from Accumulo at high throughput. You should be limited by the resources you have available, not by very tricky ways you have to write software. Ease of use is probably the first one where I'll knock the API because it is kind of painful sometimes. There are, Java is certainly not succinct. It is definitely verbose by nature, and it can get a little pedantic to always kind of go and rewrite the same sort of boilerplate over again. The API doesn't really intend to address this, and you can kind of notice this from a usability standpoint. It's not that great. Extensibility, though, going back to the original points, this is really great here because we can enable all these sorts of integrations with other products into Accumulo easily. Pig. Pig is a platform. This is taken from their website. So you can analyze large data sets. They define their own sort of high-level language. They call it Pig Latin, yuck yuck. And it's really good for doing sort of introspective on-the-fly analysis of large streams of data. It's kind of functionally, it feels like a little, it's very iterative. It drops you into a REPL sort of thing. So you have the sort of, let me run some command, let me see what the output is. It's backed by MapReduce. Which can be, I guess, its biggest downfall is that if you want to do something fast, you will be waiting for the job to get assigned, for containers to be run. There's doing some work with Tez. There's also some work with Spark. I don't know where either of them really stand, but there's some efforts there to sort of reduce that overhead of MapReduce as a sort of a first class citizen inside of the language. Inside of Pig itself, they have this nice extension point they call a load store func, which essentially means is here's an interface that lets you define how you read and write data to some other system from Pig. So obviously we have an Accumulo storage is the notion here. You have lots of other things from file formats like Avro to Parquet to HBase Accumulo to lots of other things I can't give justice to. But here's some just dirt simple. Read a file from HDFS, load in students.txt. It is a CSV or just a delimited file. We have a name, a term, and a GPA. And we can do a group by on the names. So we can then go and say, I'm going to get the average GPA for all the students in that file. Very succinct, 3 lines of code. Does a reasonably complicated thing if you were to do it by hand. So it's pretty great. Down at the bottom here is an actual example of how this sort of maps into the Accumulo storage standpoint. So you have this sort of URI notion. So the scheme is Accumulo. The flights there will be the table. So I'm writing flight information. And you have this sort of typical connection information where you have zookeepers, instance name, username, password stuff. And then you define this sort of this comma separated list of columns. So up in the relation at the top there where we loaded things into A, we have 3 columns in that relation. So relations are just series of tuples in this case, so 3 element tuples. What this really means is then down at the bottom is we have to take these tuples and somehow map them into Accumulo columns. So this fancy little string here sort of tells Pig how do you take the element in position 0 in a tuple and write that into Accumulo. In this case, the first column in a tuple would be written to the column family carrier name, the second into source airport, and so on and so forth. You can do a lot of other fancier things, but read the Pig documentation if you're interested in it. So Pig is really nice. I like it. You can do a lot of fun things around it. It's been around for ages and ages, probably longer than I've been doing big data. The storage function, the load store func interface is decent. It fits in well with the language. You aren't going to suddenly run into certain Pig Latin commands that don't work or aren't quite implemented with this. It all has a natural feel. It feels sort of cohesive with Pig itself. Like I said, MapReduce can kind of be an annoyance depending on the scope and the data that you're actually analyzing. If you're only reading 10 megs of data, doing a MapReduce job is probably excessive. It's to use, like I said, 3 lines of code to read a file, do a group by, and print it out to the console. That's pretty good. I like that. That makes me happy. The sort of irritation of it, though, is that it's one of these things that it's another language you have to learn, essentially. Excuse me. Pig Latin is a sort of thing, if you don't use it like anything else, you're going to forget how it works. Whenever I go back to it every order months, I forget how it works. I am Bill Slacum. I'm like, how the hell does this work? And I get really frustrated for 30 minutes and then realize I was just doing something really dumb. It's not entirely intuitive. It's not based on anything else. So it's not like you're going to be able to look at it and say, oh yeah, this looks like so-and-so, which I used 10 years ago. It's its own sort of thing. So it's a little weird that way. And the first of these sort of the same category of problems is that some of the novel features of Accumulo don't directly apply onto a system that doesn't support it natively. So cell level visibility is sort of the cardinal example. If you take a system that you're writing data into a cell labeled store, but there's no notion of tagging individual columns or records or cells in a record in the source language, how are you going to translate that into you're missing the ability to provide this information to begin with. It's rough from that regard, and there's not really good support because Pig itself it doesn't want to specify itself for Accumulo itself. It wants to be this generic language that works with all these other systems. So you'll see Hive is the first that sort of suffers from this. There will be some level of manual work that you'll either do via the shell with Accumulo or have some sort of Java wrapper that's going to be initializing Accumulo to some expected state for you. Number 2 is Hive. Hive is another one like Pig, which has been around for ages and ages. And one of the first, I don't want to say first because I haven't done my research, like SQL on Hadoop sort of projects. You could say, I guess in my opinion, I view Hive as one of these things that sort of sparked this idea of, hey, SQL is actually pretty useful sometimes. It's had a lot of work recently to fight against this stigma of Hive doesn't do low latency queries. A lot of that was valid, and they've actually done a lot of great work with Tez. I will honestly say as a developer and not as an employee of a company that I was shocked when I first ran a query with Tez, and I was like, holy crap, that came back in 10 milliseconds. So I will say it's pretty neat. As just an SQL system on Hadoop, it's interesting, and it's nice to sort of get back into this sort of well-defined SQL language. Like Pig, they call their extension points storage handlers, and as you could guess, there's an implementation for Accumulo. At the top here, we have some more code. So you'll see a create table statement. This should look mostly like SQL at first, and then it goes a little weird. So we create a table, we give the table, we define a schema, you have columns, and each of those columns has types. And then we get this weird stored by stuff. So this is where HiveQL, HQL, sort of differs from your standard, like a SQL 92 specification. In this case here, we're giving it actually a Java class name that actually handles the implementation of saying, how does Hive write to another system? Survey properties, serializing and deserializing is just general mapping of options here. The one that you'll always use is this column mapping thing. So like pig, we have a set of mappings to say how do the columns in each row in the relational Hive table map to Accumulo's multiple columns. The interesting one you'll note there is that :row ID, which essentially means that in this case the UID, the first column in our table, is what's going to be mapped to the Accumulo row ID. It has the same sort of perks that pig does in that you write very concise amounts of code, and you suddenly can write a SQL statement that does something very complicated like a select, a subselect query and doing an order by some column. Pretty great, one line of code. When you're doing point queries, I was saying with the introduction of things like TES on top of just the MapReduce model, you can start doing things like point queries in Hive and get back really snappy results. So it's pretty cool. I was actually really pleased when I first used this and found that it was pleasantly usable and not excessive time to wait for. The one thing where Hive suffers is that it doesn't have a good notion of inserting data. So it's kind of a knock against the stability and sort of how you use it. Back when I used it, which was pre the recent 1.0 release that Hive has gone through, there is no real intuitive way to insert data into a table that is backed by a storage handler. You kind of do this weird select statement where you give it constants and then you pipe that into an insert and somehow it magically gets to your table. Or you already have your data in Hive somewhere else and you have to do a select statement to go and insert it in there. But there wasn't a really good way to say, I'm going to read some file from HDFS and directly put it in my Accumulo table. There was always some intermediate step that you had to do. So it's kind of a knock against the usability. You kind of have to sometimes either do special research to find this sort of dark corner of HQL that differs from a normal SQL specification. Maturity-wise, though, it is well defined. You know, again, this community has been around for ages, so they have their well-defined ASF sort of policies where you can contribute, you can participate, and you'll be recognized for your technical merit. So that's always nice. So at least you can make improvements to it. Like pig, like I was saying, this is a thing you'll sort of see over and over again. There's not a good way to do sort of administrative tasks in Hive. There's no way to represent cell visibilities in Hive itself and Hive records. You kind of have to go and figure out how to do it on your own and mesh together some composite system. Thrift. So I said I would explain this. The Thrift proxy is this sort of notion that we have some extra process that we introduced that uses Thrift, and we expose a different endpoint for users to write some code in any language that Thrift generates. Thrift is pretty much just an RPC framework and a code generation tool. So it is similar to, none of you probably want to know how Hadoop RPC works, so that's probably not worth it to go into. It's really nice from a standpoint of just saying I want to define some methods about what a remote procedure call will look like, generate something that actually looks like code, and Thrift will just go and generate the stubs for clients as well as servers, and then you can just go and implement you can implement the server side, and you just call this method on the client, and it magically goes across and calls it on the server, and magically gets back to you. It's pretty sweet. This is what Accumulo uses internally for all of its RPCs. So when you sit down and hook up a scanner, this is doing all that work talking to Accumulo over Thrift. It has a lot of nice aspects if you've ever actually written RPC engines or RPC servers, such as handling varying versions. So if an older client is talking to a newer server, they can automatically realize that a field might not be present in a message, all sorts of fun stuff like that. And the other cool part is that the client doesn't have to be speaking the same language that the server is. So you have a client sitting in Python or Ruby and a server sitting in C++ or Java, and they'll just talk to each other fine. So you might ask the question and say, well, if Accumulo is using Thrift for its RPC, why do I have to have this proxy thing? Why don't I just have clients in Python that just talk to Accumulo? And it's a valid question, but I would say do not underestimate the amount of failure handling and expected failures. So rather unexpected failures and expected failures that Accumulo client actually does in normal operations. You could hypothetically sit down, write your own implementation in Python or Ruby, your language of choice, use the Thrift bindings yourself and go to town, but you will likely spend months just trying to properly implement what the actual Accumulo RPC looks like underneath. There's a lot of implicit sort of contracts about what you need to retry, when you need to retry, what's an accepted error or expected error, and what's an unexpected error, and it would be a nightmare. So the way to get around this is sort of put another shim right in between where the client and the server would sit. And this is that proxy that we were talking about. So we kind of defined this new API here that kind of exposes things that the client API would look like. So you have things like a notion of a scanner, you have a notion of writing data to a table. But the problem is that this isn't really, this is not 100% matching what the public API would look like. So here's an example Python and Ruby code that comes from what we actually bundle by default in Accumulo. I have no idea if this is readable to you, so I'll apologize. But for example here, writing some data in Python, there's this method client.update and flush. I don't know about you, but I've never seen an update and flush API call in the Java API. So it's kind of this weird sort of thing where it feels like the long-lost stepsister or second cousin that you didn't really find out about until you were 18. And you're like, oh, well, I kind of think I know what this is doing, but it's not really like what I'm expected to seeing if I was using the Java API. The sad part is that Accumulo kind of has to take this stance as well, because this is a relatively new sort of feature. It doesn't have that robustness and stability that we previously had. And as such of passing it all through this single server, we kind of have to pay a big penalty where you have to collapse all your, many clients, many servers, and you're all kind of falling down to this tiny little proxy. So it's very easy to actually overload the proxy, and very common if you actually tried to use it in production, where you would probably just knock it over and run out of memory. Like saying, maturity, stability isn't really that great. It's kind of your mileage may vary, it might change. And the APIs aren't really what you would normally expect from a sort of like a well thought out language or library in a language itself. So Ruby on Rails is a great example. There are many great libraries that are part of Ruby that are very Ruby-like. You have the language sort of develop their own meta schema or meta normalcy. I don't know what the right word I'm looking for is, but you have things, there's normal ways that you expect to see code written in each language. The proxy doesn't really encourage that. It kind of sticks you all in the straight bucket because they're all just using generated code. So people could go along, write some better APIs around it, but hasn't happened yet. Spark and Cascading are two other projects permissively licensed with the Apache software license. Spark has been in every news article like every month since mid last year, I guess. It's I always look at it as a complementary technology. It's people really like it. Same with Cascading. Cascading's been around forever. Not at the ASF though. I haven't really used it myself. There's some integrations as well as integrations with Spark, but most of these are sort of, they fall in this bucket of, you could probably do it, but you're gonna have to do some research to figure out how to do it. Closure and Scala, again, these get into the JVM languages. There's not really a good example of how you do this, and we find out recently every once in a while that maybe something actually doesn't work due to some oddity of what the language is actually doing in certain situations. 3718 is a good example of that was Scala recently. Kind of like Cascading and Scala, this is really one of these points where we want people to sort of step up and be able to actually do something, make some effort, so we can actually start moving these things towards stability and maturity. So that's all nice. You can listen to me harp and take my opinion as what it's worth. I won't be offended either way. But how does this actually translate into a concrete problem? Stanford has a collection of data, 35 million records, about 14 gigabytes gzipped. So it's bigger than something you would pull down in a normal data set. But it's all their review data from a series of Amazon reviews. So products that are sold on Amazon, people come in, give them reviews. They scrape this for a while and put it up for use. Obligatory, the source where they did the paper about this stuff is down there. I'm obligated to tell you that. But we just want to do a simple problem and see how this sort of expresses itself on these different languages. So we want to take these, it was a custom file format, convert it into CSV, just get it in a nice sort of usable way you can do things. And maybe let's see how the Java API, Pig, and Hive compare to answering the same question. So we have users using a system, so maybe we want to know what the usefulness of somebody actually writing reviews on Amazon is. Maybe they're just some person that's paid to come along and always give 5 stars to everything made by some manufacturer, right? They're paid by the companies to hopefully drive up reviews so other people buy it because, oh, this guy thought it was great. Maybe it's some big curmudgeon where they just really hate everything by some other company, so they always just -1 or 1 out of 5 everything. So, say for every time we see a user writing a review, let's get their average review score that they give. Let's see if they're skewed to one side or the other. We expect overall, they probably go to, people are typically happy people, so they're probably going to err on the side of like 3 out of 5, 4 out of 5, 5 out of 5. You'd probably expect. So the part we'll kind of gloss over here is how we actually get this data into Accumulo. Pig, like I said, we have ways to write data easily into Accumulo through Pig, but only when it's in these sort of like delimited line, or one line or one record per line, which has some common delimiter, and kind of all is nicely massaged and data is sort of, it's cleansed. So you have some level of expectancy of the data looks correct. Hive, like I said, don't really have a good way to do it into Accumulo, so let's just start from the basis of wrote some Java code, we ingested it, it's into a table that both Pig and Hive expect to use, which boils down to this common sort of paradigm, 1 record per row. So each record is in 1 row, and there are multiple columns because of the loose schema of Accumulo. We can sort of have a dynamic set of columns. We don't have to have a fixed schema. So what this turns out is I want to do this query, which is essentially a select, a group by with an average in it, right? I did it in a single threaded Java client in approximately 162 lines of code. I didn't do anything fancy at all. It was the dirt simple thing I could do. I kept all the data in memory to do the group by, because you have to look at every single element to actually compute the average, unless you do other tricky things with table schemes. And it was essentially 1 thread doing all the processing. So we have no parallelism outside of what the batch scanner is giving us. So it worked because it was a very small amount of data, and I had more than a gigabyte or 2 free to use. In Pig, we can do this in 4 lines. So, and I think it took me about 5 minutes to write, as opposed to probably an hour and a half to do in Java. Hive made my day. I just sat there and smiled for the other 4 minutes it didn't take me to do the Hive query, because you do a select and a group by, and it's pretty great. The other sort of intrinsic benefit you have with Pig and Hive is that there's actually, you get the benefit of better scalability because these systems were built on MapReduce. It's the other side of the coin. You have the, oh, well, I don't want to use this system because it's based on MapReduce and I care about low latency. Well, maybe you also care about actually running distributed, large distributed data sets and questions on those. So kind of 50-50. You have to, it kind of goes back to the original point I said where it depends, right? You have to sort of look at your problem, take stock in it, and actually say, what's best for me? I hope some of this stuff here is actually useful. I think a lot of these tools that we have already are really great. We have a lot of other options in the future that we could build on top of, but we need everyone else's help to actually do that. Credit, again, Stanford, they wrote a nice paper on this. All the code I wrote is actually up on GitHub, so you can go check it out there. The second one there is the library I actually used to ingest, which is just a little wrapper I wrote to make my life easier. All but Cascading all those projects are Apache projects. So you can go check them out there. Cascading is its own thing, as well as Closure and Scala are their own projects. And I talked. So a quick question. You can do a scan to read data, but the moment you want to do something more complicated, the shell is not going to be a solution for you. A group by I would not call simple. But yeah, and then it also goes back to the other side. Even if you are doing just a sequential scan, you're limited by a single thread. That is the shell. So you have a single client processing all the mutations. You're going to have some amount of overhead that's implicit with doing the RPC calls, deserializing stuff over the wire that could be parallelized well with a tool like Pig or Hive that you would not get out of the shell. This kind of goes back to the whole cell level visibility point. There's no language construct sort of built in that lets you specify how an iterator is set on there. Hive itself will automatically use some iterators to do things like projection on the fly, so it can sort of analyze the query, see, okay, I can push down some predicates to Accumulo. So that is basically instrumented, but it's not directly exposed to you to control. I do not believe such an optimization exists in Hive or HBase currently. Hypothetically, with the introduction of Calcite as an optimizing system in Hive, it might be easier to actually push down that sort of predicate into Accumulo. Right now, there's only some basic stuff implemented, even exposed for the Hive integration stuff to actually use. I would love to see such an API. I would love to see a document-focused API. I would love to see a general like secondary indexing-focused API. Things that can automatically generate a data table and an index table. I would love to see a graph-focused API, but I don't know of any projects or endeavors by people in the public eye right now. Yeah, that's sort of the read between the lines here. You know, there's a lot of work that could be done here, which would actually be really beneficial to everyone. I hear a lot of people, they're using Accumulo. I know they've done fantastic stuff with it, but it's either not being publicly shared, it's unable to be shared. So sort of, take it as a little bit of a call to arms to actually, do your best to try and get the stuff out, because the more you can share it, the more likely you have other people to contribute back to it and make your life easier down the road for some cost you paid up front to share it in the first place.
Thank you.
Okay.